Okay, before the break, we talked about the history of databases and um, took a preview look at MySQL running in a terminal and the setup instructions for, well, either to run it in a terminal like that or with the nice little GUI that runs as a web app and we stuff in a browser and we have buttons and nicely labeled text input boxes and buttons and labels and inputs and all that easy to work with stuff. Those setup instructions, I put them in module 1, but since I didn't get that finished till this morning, it has the module 2 due date. So it's not actually due till next week, but it'll be a couple weeks before we do a lot of that stuff. But I like active hands-on stuff, so we probably will have class examples. So we want to follow along some of the class examples when we do that. It won't go as quick as the preview mode stuff we just saw. Right, it's going to be step-by-step explanations on why we do everything, and do it for side-by-side comparisons for the concepts we're studying. We're going to get that installed, or just to start playing around with database, seeing what's there. You can go ahead and do that. I extended the due date since I didn't get that out there till like right before our class. I think I published it at like noon today. Okay, so next up is a bunch of one of those vocabulary lectures. We got the terminology for the field. We need to be using that throughout the semester. So here at the beginning, we need to go through the vocabulary lectures. The book has a bunch of this stuff. The book is very, very technical, so I want to make sure and don't skip over that technical stuff in the book. I'm trying to clarify it here, not replace it. So I'll say that. We do a lot of mixing it in with English words and things, but your quiz questions will have those technical definitions from the textbook. So, instant work to store data, right? Microsoft Word, a Word document. We can open up a Word document and start typing all our stuff there, or Excel. There's a big problem with that, especially for like programmers, software developers. You want to go read that data. Our Word, Microsoft Word, Google Docs, Apple Pages, those all make Word documents look really, really nice, right? Make our documents look really, really nice. And one of the things they do, when we type a sentence, in particular, in pretty much every document editor, if we go to put some quote marks around that, I'll put some quote instead of some sentence. If we go to put quote marks in it, it gives us those nice, really fancy quotation marks that curve towards the words being quoted. Those look nice in the document, right? Those are not Unicode. If you try to read that from a Word document or a Google Doc or a Pages sheet and run that through some of your software, or bring it into a Linux terminal with grep and try to do stuff with it, those are not Unicode characters, so they will crash it. If you ever have a bunch of stuff that you need to get from a Word document, you have to actually open it in a text editor where you will see regular looking quote marks. And what I do is I'll like highlight that and hit the find and replace keyboard shortcut so that even though it doesn't look like those anymore, it's not Unicode, it'll cause things to crash. I'll highlight that, put it in the find and replace, and then type a regular quotation mark and you have to replace them all. And that's not the only symbol, it's just that's the one you're most likely to encounter if you try to read that out of a Microsoft Word document or Google Docs or Pages. Is the Pages doc or Pages sheet? I usually just say document. People know what it is on different systems, but that's consistent across all our document editors. It's not the only symbol, that's just one that happens a lot. So that's a problem. Spreadsheets are nice and organized to an extent, right? Spreadsheets can be nice and organized, but a lot of that depends on who made the spreadsheet. Right? What's a good extreme example? Okay, some church spreadsheet, the volunteers have been working on building, keeping track of the church finances since 2003. It's probably not even, that's probably almost impossible to get through, right? It can be a mess. So it depends on who made it and all of that. There's other things like that. And with that, a human still has to sort, filter, and find it manually. It's only semi-automated in a spreadsheet. They added a few other features, but you kind of have to really know what you're doing with Excel to make use of those features. And it is also dependent on the organization designed by the people who created Excel. So you have to organize your data in a certain way. It's not going to work on just any single spreadsheet. So there's still, it's only semi-automated. Yeah, and then the human aspect, it might make sense to the person who created it, but there are other people going to be able to follow that organization and pull the data out. Hopefully the need makes sense. There's different things we have. So I guess the first few terms to look at are going to be our data models. This is one in the textbook, they give all these definitions and they sound so drastically different. We're going to take all four of those things that sound like drastically different options, but we do them all at the same time. We take those four definitions and we jam them into one thing, and that's the database tables we're creating. So really it has more to do with usage. So there's the relational model. The relationships between tables, we talked about all that the other day. Those great relationships here. Relationships, because that's pretty much what we're talking about this semester. That's what there's a whole lot of stuff we're going to fill in here. And the way they we're describing the terms in the book, it sounded like the entity relationship model was something completely different than the relational model. They had it even put out in like a bulleted list, I think, to make it look drastically different. These, we're going to draw this picture when we design these. So they're related. These are the pictures we're going to draw when we talk about this. It's a virtual representation of a real thing. Of a real thing. Something from the physical world. Basically, it's the design for our table. So for that one I did in preview mode before class, we want to make a people table. And that people table has some stuff in it. It had an ID, whatever I called it. It was an integer and all that stuff. So people are represented by that unique identifier. Had a name, age, town. What was that? I think we used text. We haven't got to bar chart yet. So we use text, integer, and text. So that's the entity. It represents virtual representation of the real thing. So we draw that picture, and then if you remember a few minutes before break, when we were in preview mode looking at the MySQL stuff, that's the information we need to make that database. So it's not a different alternative way of doing things. They're blend together. This is how we create our tables. the textbook didn't make it very clear that those were different things. I'll erase that in a moment. I got room for the next thing. Semi-structured. This is this one would be something different. So this is semi-structured is what we do with unstructured data. So I'm gonna write this is our flat files. So unstructured data but we do organize it some when we put it in that file. Right? We put it in these files for automated processes, which means we're probably going to put all of that data in at least some sort of similar format. Give it a bit of a structure. So it does have some structure, but it's generally unstructured data. But we'll organize it when we encode it. There'll be some consistency in how we put it in. So it just sort of a structure in how we put the files together. Almost like applying this to unstructured data. There, we get a little bit of formatting on it, but it would still be the alternative to the relational model. The last one on the list here, I'll read into this before I erase everything, is the object-based model. Which had a very, very technical sounding definition in the textbook. I'm going to say that our entity relationship stuff, the ER model stuff, I'll put it in my notes. The ER model stuff to design tables are the classes from the software that we're running. That needs this data. So if you're writing a big program in C++, you set up a bunch of class definitions to use in your software, your own unique custom data type for the software you're creating is what that is. And you have all that stuff in the software and you need to keep it somewhere. So basically you take your class and that's what becomes your entity in the entity relationship. And then that's what you use to design the relational model. Obviously, all of your classes follow that same design. So it's going to fill up a table nicely. It's going to be very structured data. So it sounds like it's something different, but really this is, if you write for software developers, if you're writing object-oriented programming and going to keep it in a database, because there's a lot of consistencies there already, you just take your class diagram and make your tables a one-to-one correspondence with your with the classes from your software. Trying to clear up some of what this is. The book definitely made that look like drastically different things, but there's overlap. Or if it fits better, maybe your classes relate back to the semi-structured stuff and you have a big JSON file. But it's not randomized data at that point because you're putting it together for an automated process, so you will end up with some organization in it. So there's overlap in those. We mix and match it. It's methods of doing things. And very rarely would we only use one of those methods. It's okay if I erase this. Hopefully clearing up some of those technical things because On those four especially, it gave very, very technical definition. And I didn't think that was very clear because for the most part of this class, we're going to draw the ER diagrams and make tables based off of it. Your first assignment will be to submit the diagram, and then the next assignment is going to be to submit the schema, where you write the SQL code to implement what you put in that diagram. What's next? Abstraction, I think. Yes, abstraction. This is the layer we're looking at. At what point between the actual, the computer's actually storing a bunch of binary code? We are not working with the binary code. And one of the introduction classes, you'll probably see an introduction to binary where they show you how to do binary integers. Don't really do that. If you're in a class where you get as far as seeing XSK and choose complement, that's how numbers are stored. But that simple one is an oversimplification gets started in binary. To really understand binary is unique to every single machine. So when you go to change BIOS on your laptop, for example, every laptop has a different keyboard shortcut. And like here on mine, I have this HP here. If I go Google it, the best they can do is give me a list of 4 or 5 options that might get me to the BIOS. It's fine. The binary is unique to the machine itself. We're not going to work at that level. But somewhere between that level where it's stored in binary and the actual presentation of it. Right? Maybe we grab that data. We've got a meeting here in an hour or so we grab the data and throw it in Excel and make a really nice chart that we can throw that we can show everybody at the meeting coming up in an hour. Right? And then it's just a nice colorful chart. There's not even words or labels left on there. The presentation of it. The abstraction is where are we at that level, somewhere between the actual thing and what we want to use it for. So when you hear the term physical, that is the binary. How it is physically stored as electricity in our universe. The level we usually don't work at, binary or machine language. A lot of it's probably going to be bytecode these days. Something the machine, I'm going to write machine known language. Sorry, because if I say machine language, that is a term for binary. One of the things the machine knows, but it might be stored in bytecode or assembly language or pure machine binary code itself. But it'll be in something that the machine knows. That's how it actually exists in the physical universe. Logical is the organization. Which the two we're going to look at this semester, it's either going to be a table or a key value pair. How is it organized in there? And then the view is the presentation. Are we printing out the table directly? Are we going to generate a report from it? Or are we going to put it in a really nice, colorful chart to show people? Then we get into a whole nother thing, right? We might look at that some because it does relate to databases, but when we go to put it in a chart, we can influence people very, very easily with charts. Red and yellow are good colors. Right? We see those on all the fast food logos because colors red and yellow make people hungrier. So if you want to convince people of something and you know the meeting is gonna happen right before lunchtime, it's probably a good idea to put a lot of reds and yellows in your chart. If you know that people aren't gonna be happy with the data you have to show them, you can make it look really, really nice. Go in Excel and turn on like every little feature you can, get the shiny colors and rounded corners where it gets just a little bit of 3D look to it and make it look super, super nice. Because humans are a visual species. They'll completely ignore the numbers and be like, wow, that chart looks great. Or if you need to downplay some stuff, make it a really boring chart. Take all the labels off there, put some really boring colors on, minimize it, make it where it's almost hard to read. I'd step in there. That is possible. I think everybody knows that's possible. So we're doing that. That's at the view level. And knowing that is kind of important. Knowing those differences are the choice to do it is on you, but you also need to be able to recognize when somebody else is doing that, right? Somebody else comes in with a you show up at a meeting at 11 o'clock right before lunch and somebody just has the most beautiful chart you've ever seen in reds and yellows. I want to recognize pause and think and be like, oh wait, are they using all those little tricks to try to manipulate me into liking what they're saying better? And step back and actually look at what the labels on that chart are saying. Make sure you're not being manipulated. So I say abstraction, just a couple terms that we're going to use a lot. So now into things that are going to show up just in our normal, as we talk about databases. So instance. Software developers probably have already had the usage of the word instance drilled into their head. That's a snapshot of our data. It's not the design, it is the data in those tables. Right? If we set up our design, we fill up those tables with data, and then we look at the data itself. That's the instance of the database. How is ours different? Because somebody else we could have given that design to two different people, and each one of them fill it up with different data. Right? Same design, like the templates in Access, Microsoft Access database, small office, good for up to a few hundred. I've seen some people get up to a few thousand customers, but for a small company, that's perfect. And you don't need to go rent big, powerful servers if you only have 20 customers. But they have templates. But different people will fill those templates up differently. Or a contact list is a good example, right? Right now in our pockets, every one of us has a contact list. And it was most likely either an Android contact list or an iOS contact list, but there's not much difference between them as far as design, right? They're very, very similar, but that's the schema. Our next word. But every one of us have different contacts in our contact list, right? That's the instance of a contact list. Whereas a schema is that general design we're talking. Pretty much only two in modern world, right? It's either iOS or Android. Microsoft had one at one point, and then they did something that's kind of a crossover way between iOS and Android, so that it's fully compatible with both of those. Since nobody bought the Windows phones. Schema is design of our database or database, however you prefer to say the word. Or this is America. We're kind of sloppy with our English is an awful language, and in America we're even sloppier with it. And so however you want to say that word, people know what you're talking about. And not not the picture design, not the ERD diagrams. This is the code. So like the code to create that design, not the picture of it, is referring to that. Okay, if I erase this over, half over here about abstraction. Hopefully all that made sense. These words are going to be used a lot, and some of the ones in the book just, it didn't seem very useful. The data manipulation language. I'll write some words, but DML. Yeah. Data definition language. Or for the rest of the semester, we're going to say DDL, because that's kind of a mouthful. Yeah, I'll write some words. We don't need much here. Work with data. Create database. I'll put it that way. And what I actually wanted to hear instead of the words is DML is for the instance, and DDL is for the schema. And the biggest thing that I think our textbook did a decent job mentioning it. I read the chapter really, really quick. I went through especially the first couple chapters really, really quick. Try to get ready and get a little bit ahead, but yeah, so DML, DDL, we'll say those a lot. Is it the data that's in our database, or is it the database itself? And I'm just going to write it as an equation. So DML plus DDL equals structured query language. They're not different languages they're not different programming languages that we're going to work with. They're procedural programming languages, so we're not, but we're not dynamically defining new functions like you might have seen in some of your programming classes where that word shows up, or what you might think of with like. In those, we tell the computer how to carry out an instruction. But on C++, especially, we can set aside specific blocks of RAM and the RAM chip, and we tell the computer how to do stuff. Imperative is the term for that. SQL, SQL, and most people go ahead and pronounce pretend like there's vowels in there and pronounce it SQL, because that just flows off the tongue a little bit easier than an acronym. Structured query language is a declarative language. All of that stuff, the computer knows how to do that stuff. We just tell it which one we want it to do. So not quite to the level of encoding. Not an encoding thing like HTML or XML and JSON will be encoding our unstructured data near the end. That we're just going to encode it in a certain format that the computer can work with later. So it is a language we're doing stuff dynamically, but we're not making new things to do. We don't have to tell the computer how to do the stuff. Everything we're going to ask for, it already knows how to do. We just have to tell it which ones we want and in which order. I'll write this out. Structured query language. Which I don't remember. I didn't say anything about that when I was talking about the history, did I? Okay. The one in 1973 from earlier's lecture about points about history, the researchers put together, I relational database. That's where structured query language was invented. And then in 77, Oracle really, really refined structured query language and made it easy for humans, easy for the average human, so you didn't have to be a computer science expert to create structured query language. You'll notice that in the preview mode, those almost look like sentences. We read them like select name from the people table, from people. It almost reads like a sentence, so it's really easy to work with. That's what those guys at Oracle created. It was almost in place, but it was still not quite there. But more than one, I'm talking about more than one thing, giving it the same name, right? So SQL is a category. It's not a single language. Earlier, I typed the word auto increment a couple times. That's one of the first words I look at to see which flavor. This sometimes it's, well, MariaDB, the one actually already used for this class, it uses auto underscore increment. Sometimes the auto increment is one word. Sometimes it's two separate words. Sometimes it's a completely different word altogether. So that's a good place. That's one of the first things I always look at to try to figure out which language I'm typing in specifically, because unlike our normal, what we normally think of when we say programming, C family and Python and Go and Kotlin and all of those, they don't all have a specific name. We say SQL, and it has to be something very, very unique before it switches from being called SQL, like Link, L-I-N-Q, which a lot of people do still refer to SQL because it's not very different. So they don't necessarily get their own name, but there's a whole bunch of them. And we will be using that some in this class. It is one of our major course learning objectives, but it's really just starting into it. We won't be doing anything super complicated. The DBMS 130 class, this is a prerequisite for, that's the SQL specific class. That's the class where you show up for every one of your assignments just to do a bunch of stuff in SQL. And then the lectures are just examples of doing stuff in SQL. And the textbook is examples of a, like your SF 120 book, for those who've had that class, where it's just examples of code that's been written. You read through that. And then show up in class and you work through examples in live time instead of reading the finished version of the textbook, because when you see the finished version, you miss how to get there. And the how to get to that finished version is the more important part. That confuses a lot of people when all they do is look at finished versions over and over again and miss some of the steps on getting there. Same thing, it is a programming language. It's just all the stuff we were programming with it already knows how to do. So we just have to throw out those keywords or function names if that helps you to think of it. That was the terms that I noticed in the book that we're going to use a lot, especially these. It was very separated. And then another one that looked like it was two separate lists. Those models, we're gonna take those 4 different models they said and match them into one single thing, and then that's what we're working with. And then we control it with DML and DDL, which are just the two halves of C. Hopefully that clarified a couple of the points from the textbook. Obviously, please still read those with clarification points on those technical definitions, and your quiz asks about the technical definitions, not the clarification points on it. Anybody have any questions about that? I see head shaking no here in class. I'll give it a couple seconds. Okay, so that finished up what I was wanting to talk about today. And for those who haven't had me in class before, maybe give you an example of how I lecture. You might notice I'm very easily distracted. Feel free to use this to your advantage. The quizzes and stuff are based off the textbook and and you have all those other resources there. So if you have something you're particularly interested in that's not wouldn't be covered in the normal thing, feel free to ask questions and we'll talk about that. Or about the part you're actually interested in. See some examples of that. So there's gonna be some example stuff, some conceptual stuff, lots of pictures. Have anything else? Oh, database engine, I'm gonna talk about that on Tuesday. Okay, that was a few seconds of silence. I assume that means there's no questions from the Zoom call. If anybody has any questions, let me know. Our scheduled block goes until 3:50. So until 3:50, I'm just gonna be sitting around waiting for questions to come my way. And then I'm gonna eat lunch. I might eat lunch between now and then. Maybe go walk out to the car and grab my lunch tray. But then after that, I have office hours scheduled. So I'm gonna be sitting around waiting, just ready to answer your questions until the 6 o'clock class tonight. So if you have any questions, send them my way. Please use our time productively. And that's that. There's different things, get set up stuff, reading, jump through the quizzes, look around. Try not to work too far ahead in the module, because again, I use the standard statewide shell, and I know I am definitely changing. I'm gonna be making changes, so try not to work too far ahead. Otherwise, I will see you all on Tuesday, and we'll continue from there. Everybody have a good weekend.